lines and transversals. Our learning targets for today are I can identify congruent angles when a transversal intersects parallel lines, and I can find angle measures when a transversal intersects parallel lines. Now looking at parallel lines and transversals, so in my picture below we have lines X and Y are parallel lines. Parallel lines are often denoted with these little arrows on the sides here that show me that these lines are parallel. And then line T is what we call a transversal, or a line that intersects them. Now when I have parallel lines cut by a transversal, I have different types of angle pairs. These angle pairs have different relationships with one another. Now when I talk about these angle pairs, I'll have interior and exterior angles that are created. So when I look at my parallel lines, if I'm the four angles inside, that would be the interior. So angle D, angle C, angle E, and angle F are on the interior. And then the angles on the outside of the parallel lines, so angle A, angle B, angle G, and angle H, are in the exterior. Knowing the interior and the exterior will help me with these different types of angle relationships. So I have 5 different types of angle relationships when I have a parallel lines cut by a transversal. So the first type is vertical angles. So vertical angles are pairs of opposite angles formed by intersecting lines. So in my diagram, I have 4 different types of vertical angles. The first is angle A and angle C. Then I have angle B and angle D. Then I have angle E and angle H. And then I have angle F and angle G. These are my 4 vertical angles in my parallel lines cut by a transversal. Now the relationship of these angles, if I look at them, they look to be the same size, which in fact they are, so they are congruent angles. So if one has a measure of 50 degrees, the other would have a measure of 50 degrees. Now the next type of angles that I have are straight angles. Straight angles are angles that form a straight line and add up to 180 degrees, which are also called supplementary angles. Now in my diagram above, I have many different straight angles. I could say that A and B are straight angles. I could say that E and F are straight angles. I could say that F and H are straight angles. I could say that B and C are straight angles. There's many other different types of straight angles that I could have. These are just a few. So again, straight angles are supplementary, so their relationship would be add up to 180 degrees. Now I have alternate interior angles. So these are angles on the inside of the parallel lines and then on opposite sides of the transversal. So remember, the interior was the area here. So if I'm on opposite sides, the 2 types of angles would be angle D and angle F. That's an example of alternate interior angles. And then angle E and angle C. That's my other type of alternate interior angles. Alternate interior angles are congruent. So again, if one has a measure of, let's say, 40 degrees, the other would have a measure of 40 degrees as well. Their angles have the same measure. Now I have alternate exterior angles. So alternate exterior angles are just like alternate interior. However, they're angles outside the parallel lines and on opposite sides of the transversal. So again, the exterior were the angles that were on the outside. So if I'm looking on the opposite sides of the transversal, my 2 examples would be angle A and angle H, and then angle G and angle B. Those are my 2 types of alternate exterior angles. And again, just like alternate interior angles, their relationship is congruent. So their angles will have the same measure. And then my last type of relationship are corresponding angles. So corresponding angles are angles in the same relative position or angles in matching corners. Now I have 4 different types of corresponding angles. So notice angle A is in the top left corner of line X. Now if I look at line Y, the top left corner would be angle E. So angle A and angle E are corresponding angles. Now my top right corner would be angle B for line X, and then my top right corner for line Y would be angle F. So B and F are corresponding angles. Then I'd have angle D and angle G as corresponding angles, and my last corresponding angle would be angle C and angle H. Now corresponding angles are congruent, so again, these are angles that have the same measure. Now looking at this example, I'm given an angle measure of 75 degrees. I want to find out all the other angle measures in my diagram. Now using my angle relationships, I can find what those angle measures are. So notice the top left corner is 75 degrees. The angle right next to it would be 105 degrees because these make a straight line. So 180 minus 75 would give me 105 degrees. Now the angle below that 105 degrees would be 75 degrees. I could say that it's a straight line with the 105-degree angle, or I could say it's a vertical angle with my 75-degree angle. That would make my angle to the left of it 105 degrees, because again, the 105 degrees angle and the 75-degree angle are supplementary, or I could say that the 105-degree angle is vertical with the 105-degree angle. Now, if I go to my angle here, this angle is going to be 75 degrees because my original 75-degree angle and this angle are corresponding angles, and corresponding angles are congruent. Now I can say that the angle next to it is 105 degrees, again, because they're a straight line, or because this angle here and this angle are corresponding. Now I can say my angle in the bottom right corner is 75 degrees, because again, these two angles make a straight line, or I could say it's a vertical angle with my 75-degree angle. And then my last angle is 105 degrees, because again, I have vertical angles with the 105 degrees or a straight line with my 75-degree angle. So notice I only have two different types of angles here. I have congruent angles or supplementary angles. So when I have parallel lines cut by a transversal, they're either going to be congruent or they're going to be supplementary. Looking at a few more examples, I have line R is parallel to line S. The measure of angle 2 is 55 degrees. I want to find the measure of angle 3. How do we know? So angle 3 and angle 2 are vertical angles, so angle 3 will be 55 degrees because they're vertical angles. Looking at number 2, find the measure of angle 7. How do we know? So the measure of angle 7 will be 55 degrees, because if I notice, angle 2 and angle 7 are alternate exterior angles. I know that alternate exterior angles are congruent, so therefore angle 7 would be 55 degrees as well. Looking at my last examples, I want to determine if the statement is true or false. So looking at the first one, angle 2 and angle 8 are corresponding. 2 and 8 are not corresponding, so this would be false. They're not in matching corners. Angle 2 and angle 6 are corresponding angles. Angle 3 and angle 5 are congruent angles. Angle 3 and angle 5 are not congruent angles. They are supplementary angles. So angle 3 and angle 5 are what we call same side interior angles. If I'm on the same side, whether it be on the interior or the exterior, they're going to be supplementary angles. So this one is false as well. Angle 1 and angle 8 are alternate interior angles. This is false. Angle 1 and angle 8 are on the exterior, so these are alternate exterior angles. Angle 5 and angle 8 are vertical angles. This is true. And angle 1 and angle 7 are supplementary angles. This is also true. Again, angle 1 and angle 7 are same side exterior. Any angles that are on the same side are supplementary. In this lesson, we learned parallel lines cut by a transversal create different angle pairs. Those angle pairs being vertical angles, alternate interior and alternate exterior angles, and corresponding angles, which are all congruent, and then straight angles, which are supplementary or add to 180 degrees. That's a wrap on this video. We'll see you in the next one.